To make ultra-thin glass, manufacturers use standard materials such as lime, sand, soda, and potash. A worker measures the secondary, smaller ingredients manually and adds them to the batch. These ingredients enhance qualities like optical clarity or electrical sensitivity. The cart transfers the batch to a mixer. As it blends everything together, they add bits of broken or waste glass to it for recycling purposes. Once it's been thoroughly mixed, a lift raises a funnel-shaped container up to the base of the mixer, and the mixer releases the batch into it. A worker hauls the batch-laden funnel tank to the next station. There, a crane takes over and lowers the tank onto a feeder system just above a gas and electric furnace. A trapdoor opens at the funnel's base, and the mixture flows into the feeder mechanism. It's a kind of shovel that slowly pushes the mixture into the furnace, which has been fired to a blazing 2,732 degrees Fahrenheit. The shovel continuously adds more ingredients to keep production flowing. Glass production runs 24/7. The melting glass reaches the consistency of honey. The molten glass flows out through a narrow slit, and this slit establishes the ultra-thin dimensions of the glass. Cooling the glass slowly relieves internal stresses as the glass solidifies. Ultra-thin glass can be just 25 microns thick. That's finer than a hair. And it's this thinness that makes it so flexible. The glass bends to loop down and up across rollers as it journeys forward in a continuous nearly 2-foot wide sheet. And unlike ordinary glass, it doesn't crack. It then travels past tiny cameras and laser sensors that look for defects like bubbles. Another lab worker places a bigger segment of the glass under a cutter. He aligns it correctly and then activates the cutter. It scribes the glass so it can be broken on this line, creating small screens for smartphones and smartwatches. A lab technician examines the glass for scratches under a bright light and confirms that it's undamaged.